Hey guys, so this is going to be the section about energy production. Now, in this section, we are going to cover a couple different things. So let's go ahead and get started. The first things first, what does ATP stand for? Now, we know that A is going to stand for adenosine, but what about the TP? We know that the P stands for phosphate. So now is it going to be monophosphate, diphosphate, or triphosphate? Well, I think the T is going to stand for tri. So it's going to be adenosine triphosphate. That means it's going to be an adenosine with 3 phosphates attached to it. Next up, during photosynthesis, what happens to the solar energy from the sun? Well, there's 2 ways of looking at it. Number 1 is that we store the solar energy, and that is traditionally how we look at it, because it's kind of like taking the sun's energy and making it into a physical form. But another way of looking at it is we're using the sun's energy to create physical energy that we can grab on this planet. See, the solar energy that comes from the sun goes into that formula for photosynthesis. And in that formula, we have 6 CO2 plus 6 H2O. Now, that sun's energy is going to come down. It's going to heat up our water molecules. And what it's going to do when it heats them up is that it's going to break the bonds that hold hydrogen and oxygen together. And that extra hydrogen is going to end up going and attaching itself to our CO2. Now, a couple more things happen in which CO2 ends up losing some of its oxygens, and that's fine. That's okay. These things happen. But at the end of it, we end up creating glucose. And glucose has a lot of energy stored in its bonds. So if I was to answer during photosynthesis, what happens to the solar energy from the sun? Well, the solar energy goes and helps break water in order to form glucose. Now, what is the form of energy produced by cellular respiration? This one's actually pretty simple. Cellular respiration produces our answer for number 1, ATP. Because remember, we take that glucose and we end up breaking it. And in the process of breaking it, we release some of that energy that is stored in those bonds, and we're going to get ATP. Now, cellular respiration is broken down into 3 steps: glycolysis, the Krebs cycle, and the electron transport chain. And we went over those 3 steps. But in particular, you got to remember, we end up getting to the electron transport chain, and it's the movement of hydrogens that turn ADP into ATP. So that is why we say that the energy formed during cellular respiration is in fact ATP. Now, how much ATP is produced during each one of the steps? So this one's actually pretty simple. 2 of them are the same, and one of them is a big number. So glycolysis and Krebs cycle, either one of them could be 2, and electron transport chain has to be 32 because that's our big boy. And another way of remembering it, ETC, extra thick and chunky. Extra thick and chunky. This one's extra thick and chunky in ATP. That's why he has the biggest amount of ATP. Now, which of the following formulas is for photosynthesis? Remember, plants do photosynthesis, and plants take in CO2 and water and some sunlight. And what do they come out with? Glucose and oxygen. So it's actually number 1 for photosynthesis. The one at the bottom that we see right here is actually for cellular respiration. Let's go down a little bit more. So now we're looking at a chloroplast, and we can see that we have the Calvin cycle and a light reaction. A lot of stuff going on here, a lot of jazz. So how did the Calvin cycle attain the hydrogen needed in order to create the glucose? All right, so we've seen this one before. It's actually not too crazy to think about. Like we mentioned before, the sunlight breaks the water and ends up coming over here into the Calvin cycle. If you want to get more technical with your answer, you can check this out. We had the NADP, and it's the one that ended up taking that hydrogen across into the Calvin cycle, where it ended up combining with the CO2 in order to form our glucose. But either answer works. How did the Calvin cycle attain the hydrogen needed? When the water broke, the hydrogen was able to transfer over to the Calvin cycle. Or you can say NADP plus attached hydrogen to it and carried it into the Calvin cycle. Either one of those answers works. Now, the next one up. ADP stands for adenosine diphosphate. ATP stands for adenosine triphosphate. Oops. When ADP becomes ATP, what is the thing that changed? Hint, think di and tri. Okay, so if we went from diphosphate, and di means 2, to triphosphate, and tri means 3, then that means that we went up 1 phosphate, meaning we've attached an additional phosphate onto our molecule. Now, And then we're going to have two more questions. So here we go. Question, whatever number this is actually. The formula for cellular respiration is C6H12O6, otherwise known as glucose, plus 6 oxygen, and it's going to give us 6 CO2 plus 6 H2O plus some ATP. If there was no new CO2 being made, what would you predict? My bad, not CO2. If there was no new C6H12O6 being made, what would you predict would happen to the mass of the plant after some time passed? So, what this question is saying is we are no longer making more glucose. But you have to remember, we still have some glucose inside of us. So we're not making more glucose, but we still have glucose inside of us. So what would happen to the mass of the plant after some time passed? All right, so if it's still doing cellular respiration, let's look at the products. These go in, and what comes out? Water and CO2. CO2 is a gas. CO2 is going to leave. So over time, we're losing more CO2, more and more CO2. So my prediction, I think the mass would go down after a while. Just because we're not making more of this stuff. Like, we're not making any more glucose in this scenario, but we're still doing cellular respiration from the glucose that we already had. And every time we do cellular respiration, we're breaking it down and we're getting water and CO2, which means we're losing a little bit of mass every single time. Anyway, let's go to the very last one. What are the products that plants produce through photosynthesis? Okay, pretty simple. Photosynthesis. So we've seen this 1,000 times, so let's actually go back up to the formula that we had over here. 6 CO2 plus 6 H2O plus sunlight is going to give us glucose and oxygen. Glucose and oxygen. That's a really important thing to remember. Plants give us oxygen, and that's super duper important because without it, we wouldn't be able to survive. And it's funny because we need oxygen for cellular respiration and we need glucose for cellular respiration. And we get both of them from plants. Ain't that something, right? But anyway, guys, that's it for this section. We'll see you at the end of the next section. Bye, guys.